All right. Welcome back to another fun, riveting lesson in algebra. Today we are talking about choosing a data display. We are in Chapter 8, Section 4. Title your notes, and here we've got a couple of definitions for you to add. We are distinguishing between qualitative data and quantitative data. Qualitative data, that refers to labels or non-numerical entries. So that's something where if you're trying to add them up or finding a mean, like the average of those numbers doesn't make any sense. And we'll have a couple examples in a minute here. Quantitative data, so that refers to numbers that represents counts or measurements. So finding the mean, finding the average would make sense in that case. Okay, so let's look at a couple of examples here. All right, I want you to pause the video here, read through these, and then answer them yourselves on your paper. Answer them, and then we'll go over them. So pause now. All right, so let's look at prices of used cars. Does it make sense to find the average cost of a car at the dealership? Yes, that makes sense. So this is quantitative, right? Because it makes sense finding the average. B, jersey numbers. Notice they're trying to trick you here by saying numbers, but it's jersey numbers on a basketball team. Does it make sense to find the average jersey number? The average jersey number on this team is 19. That doesn't make any sense, right? So this is qualitative. Even though they're trying to confuse you with the numbers here, it's still qualitative because adding these up or finding the average does not make any sense. Lengths of songs played at a concert. That makes sense if I told you, yeah, the average song they played at that concert was about 3.5 minutes. So that would make sense to find an average. Zodiac signs of students in your class, that one's easy. That is qualitative. So we've got quantitative, qualitative, quantitative, and qualitative. All right. Choosing and creating a data display. Okay, so we've got a few different ones that you've already come to know. All right, we've got, and make a note of yourself for these. We've got a bar graph. Okay, bar graph shows data in specific categories. For example, weekdays or different classes like Mr. McFarland's class and Mr. Renault's class and Miss Gerard's class and so on. You could compare those. Then we've got a circle graph, or sometimes named a pie chart. That's data shown as parts of a whole, and this is important. Parts of a whole, so you might want to highlight that for yourself. Okay, then a line graph shows how data change over time. A histogram, and this often gets confused with a bar graph. A histogram shows frequencies, okay? And those frequencies are in intervals. So we could say an age range. From 5 to 10 years old, there were this many kids. From 11 to 15-year-old, there were this many kids. So frequency is how many, how often that occurred, and then the interval would be down here. All right, then we've got a stem and leaf plot that we just looked at. That shows us how it's distributed. Here I could see, well, we have a cluster here on the low end in the 10s and 20s, right? That would usually come with a key. And then a box and whisker plot shows the variability, all right? So how is it spread out? I can kind of see that here a little bit, but this shows it a little bit better visually. And it uses those 5 numbers, splits it up into the quartiles. Then we've got a line plot, or sometimes called a dot plot. On a line plot, you'd make these little X's, or a dot plot would just be dots. And that shows the number of times each value occurs in a data set. And think about it, what measure would this show right away? Number of times. Which one shows us, oh, this number occurred the most? Occurred the most, that would be the mode. So I can easily see the mode in a line plot or a dot plot. All right, and then finally we've got a scatter plot that shows a relationship between two data sets. Okay, important here. These are between two data sets using ordered pairs. All right, so let's choose a data display for this. Let's see, we've got an eye color survey, and we have a number of students here, right? And the students have all kinds of different eye colors. This makes up a total number of students. So I could display this in a pie chart or a circle graph. All right, in order to do that, I would want to add up all of these to find the total. So the total here is 140 when I add all of these up. In order to make a circle graph, you want to know the total, and then you want to know how much of the total is each part. In order to figure that out, we find the percentage by taking part to whole, right? A circle graph shows parts of a whole, percentage is part to whole. So we would take the 63 and divide that by 140. All right, so I want you to go ahead and do that. Fill in this chart right here on your paper. Pause the video, fill that in, divide them all by 140, and then to find the angle on the circle graph, we want to multiply it by 360. So divide it by 140 to find the percentage of the whole, and then to find the angle, multiply by 360. So go ahead and do that now. All right, dividing by 140, multiplying by 360. Hopefully you've filled in that chart now. Okay, divided all of these by 140 and then multiplied by 360. That gives you your angle. Okay, make yourself a little circle, put a little cup on there and draw around it if you don't have a compass. All right, and then here, these are the angles you should have gotten. All right, so now we have brown eyes are 162 degrees. So you could start anywhere on your circle. You could just make a vertical line or a horizontal. I like to start with a horizontal line, right? So I'd say, okay, brown 63 is 162 degrees. So I make a line here, and then a couple things you should know. You don't have to measure this accurately, but we should know 90, right? That's a fourth of the circle, and 180. That would be a half of the circle, straight across. So 162 falls between a 90 and 180. So somewhere in between there is where I would draw my line. Okay, and then I move on to the next one, 95. Well, we know what 90 degrees look like. That's a right angle. So somewhere around 90 degrees, a little bit more than that. Okay, so we're estimating, and then we label that blue. That's 37. Next up is hazel. 64 is a little bit more than 45 degrees. So somewhere around there. Hazel, and that's 25. Label that. And now we're getting into the smaller parts, 26 degrees. Want to split this up. What's important is that if you have fewer degrees, it should look less than the other one. So amber shouldn't turn out to be a bigger slice than gray. Okay, I'm not going to look exactly and measure them exactly, but we want to at least make sure that the bigger parts are still larger, all right? So we've got green, somewhere around 20, 26 degrees. That's what we're going for, and then split up these last two. Okay, so we've got gray and then amber. So that's how you would set up a circle graph or a pie chart. All right, here we have another data display. So this time we're comparing two sets of data. All right, we've learned a few ways to do that. One way, you could set up a back-to-back stem and leaf plot. But with these stems, you would have a bunch of numbers on both sides to fill in, yada, 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 and so on. So actually what's better for this one here would be a double box and whisker plot. So this one's really easy to see. If I look at all these numbers, I have to pick out to see what's the highest and lowest. Once it's on a box and whisker plot, it's really easy to see, okay, 82 is the high, 59 would be the slowest, and then I can see, okay, the speeds on Interstate A are more varied, but overall, the speeds on Interstate B are higher. Okay, so that's a nice visual representation for that. Okay, ladies and gentlemen, that's all the fun we're going to have with this lesson. Good times in the Matherhood. Check in again next time for another fun lesson.